We hope you've enjoyed today's sessions. Today's final talk is brought to you by Mohamed Nsiri, who is a senior product manager at Canonical. Mohamed will provide a step-by-step guide on how to benchmark a database management system. He will explain how to assess the performance impact of any change in memory, CPU speed, and other considerations, and how to universally compare different setups. Mohamed, take it away.
Thanks for joining, everyone. So today I'm going to talk to you about how to benchmark database management system, hopefully the right way. And we are going to start by exposing the most common anti-patterns of database management benchmarking. Then I am going to present what I think of as the recommended benchmarking protocol. Then we will show a demo and we'll finish with some conclusions. So let's start. The first, anti-pattern of database benchmarking is really to rely on public benchmarks. And why is that? It's because you cannot, generally speaking, draw any meaningful conclusions from that. If we take, for example, these two benchmarks, the first one at your right, which was done by Ingress, and mandated by EDB, it shows that Postgres can be anything between 4 and 15 times faster for the specific, test. And then if you see at your left, then MongoDB actually did write a report where, they were responding to this first benchmark from, Ingress, and they claimed actually that MongoDB was up to 240 times faster than Postgres in some cases. And even if, those results might be true if you configure the database in a very specific way, just to optimize for that particular workload. In my opinion, those results are not really meaningful because, first of all, you might not be able to reproduce them in your own environment because they don't match your SLA, like durability SLA or availability SLA, or those optimization don't make sense in your own environment. The other thing that I would advise, because of which I advise against, let's say, relying or giving any credit to public benchmarks, is that public benchmarks make it look like benchmarking database going from point A to B, and you will be able simply to apply that to your environment. But the reality is that when you have a lot of different application and a lot of different deployment, as many companies do, then trying to apply that to your application might not end up, let's say, ending up in the same target point where you originally, was hoping for. And therefore, I think the only thing really to take from public benchmarks are, just the fact that it might be possible to reach those figures, but not anything more than that. The other typical, anti-pattern that I often see is to rely only on the results of popular benchmarking standards such as TPCC. And I would like to make it clear that the problem is not TPCC here. Actually, I think it's a quite well-spec'd, test. But the problem is how we interpret the result and how we, make projections based on those results on what you can have actually in your own environment. And let's explain why is that. So if we start by the schema design, in TPCC benchmark, the schema design is highly normalized, and it's actually far from being the case in many companies, at least in my experience. Most of the application, I work with have some form of denormalization to speed up certain type of query. And I try to divide, let's say, the most common schema in 3 ones. The first one, what I call here the single table design, where basically we have everything in one table, okay, pretty much. So you have a primary key, a set of, normal columns, and then you have a set of composite columns that contains, JSON data or blob data or other type of blobs. And the other type that, of design that I did see, which I call here the single root, is basically when you have a single parent table and then a set of child tables, and only at one level, meaning that those child tables do not have themselves other child tables and so on. And then the star schema is quite well-known one. It's used specifically in OLAP and analytical use cases where you have a set of dimension tables and then a fact table that reference those dimension tables to represent some facts like transactions. The other problem is that, at least I can raise here, is that from durability perspective, TPC mandates that basically you need to rely on a stable medium or a durable storage medium to provide durability, meaning you can only consider a transaction committed only when the changes were committed to like a persistent volume. But we see more and more systems that are basically relying on what we can call network durability, like the quorum-based system, where basically if the change was replicated to a given number of instances, then it's considered safely replicated, even if it was not yet persisted into a persistent volume. The other thing to say here is it is about isolation. So in TPCC, there are like specific tests to conduct in order to make sure that the database supports a certain number of isolation levels, like serializable, repeatable reads, and so on. But in my experience, at least, most applications are written with the read committed, transaction, and they are happy with it most of the time. And I think in some cases, you can see snapshot isolation, but it's far from it does not represent the biggest majority of application. And here again, I'm not saying that those isolation level, like the higher isolation level, do not make sense. Actually, I think of them as a great tool that can help you solve complicated problems by pushing them down to the database. But here again, I'm just trying to say that the results that you might get from such standards do not reflect actually your case. And another big concern for me is the client stack that is not yet, or not at all spec'd in the TPCC case, and it's considered mostly as an implementation detail. So here I just give the example of, like batching, that is considered like pure implementation detail, and it is actually the case. But the problem is that those like features like batching at client side, but not only, here I mentioned as well pooling, fetch size, and caching can have a big impact on the overall performance of the application. And that's why if you do not specify that part at all, then you can have very different and very varying like benchmark for the same application just by changing some knobs. Yeah. And one of them that I always say that it's probably like this optimization to think of is the fetch size, which basically hints the driver. That is, unlike what many people think, not that smart. And if you tell him you should expect 300 rows, if we talk about a row-oriented relational database system, then he will try most of the time to allocate memory or enough memory to actually hold those 300 parameters without actually checking whether that's true or no, and without making like any dynamic adaptation, except few commercial databases. And this parameter alone can have a big impact just by, if it is set correctly, if it is tuned correctly, can have a lot of impact by reducing the number of round trips that you will have between the client and the database. Batching is obviously another example. The hardware stack, so it's not at all like constrained, but it needs to be disclosed as part of your TPCC results, if you would like to call them TPCC results. And while I understand why it's very complicated to constrain the hardware, because there are a lot of hardware parts, there are a lot of difference and variance, like even if you take a NVMe device, then it's not obvious how to spec that, because between one drive and another drive, you can have very different performance characteristic, not only from IO's perspective, but as well on the behavior side at different fill ratio, like, a drive at 80% of fill ratio can behave very differently, when it is filled at 95%, and it as well differs from vendor to vendor and so on. But even while knowing that this is difficult, it sometimes leads to those kind of, results where people are claiming, like 707 million TPMC, which is the most used metric or exposed metrics when we are talking about TPCC. And this was achieved with more than 1,500 servers from 3 zones. So of course this might be well possible, but typically your database would consist of a database deployment would consist of a few servers. When I say few, really it can be 1, 2, 3 servers, and I think that makes the bulk of database deployment. And in some cases you can reach like slightly higher than that, but it would be extremely rare to go above like 10 databases, and I would say that is true for 90% of the deployment. So if you are in those 100% that would need much more, like in this case, then yes, this applies to you. But for the biggest majority of the user, it's really just unrealistic numbers that are not really useful. Another thing is the workload itself, and for me this is like the biggest problem at the end of the day. Even if TPCC, workload and test were made to be as generic as possible, they're still generic, and in some cases as well they are a bit limited. Like in this case I'm highlighting the fact that it was designed to not have more than 10 users basically per warehouse, and you can think of a warehouse as a table. So in terms of concurrency is limited to 10 basically. But it might not be the case at all in your case. You might have a much higher level of concurrency, or you might have lower level of concurrency. So trying to draw any conclusion based on the TPCC results for your use case is, not meaningful at all. So you should not, I think, rely on TPCC results, because it's a bit like the LTP, WLTP, standard when it comes to car fuel consumption. It is useful because it's an objective measure, but it does not tell you at all in reality what will be like your consumption or your CO2 emission and so on. It really depends on your driving habit, and I think you should think about TPCC in the same way. The other typical anti-pattern is to benchmark using highly over-provisioned hardware. Basically, for example, the data set fits completely in memory, and then you claim that this setup works great. So of course, if you and your company can afford to have like a big machine where all the data set fits in memory, then that's fine. Try to stay in that company for as long as you can. But if it's not the case, then this is not realistic, and you need to care for that. The other typical example where you have no or very low contention on CPU and IO side, basically you have a lot of drives that are striped, and then you have basically no contention at all, and you claim victory. And here I was just trying to explain the difference in pictures between over-provisioned hardware and real-world applications. The other typical, I would say, anti-pattern or mistake is to benchmark in static condition, meaning that you don't have any variability in network jitter, workload profiles or loads, and that you have no failures. And even if some people might try to simulate some failures, I would say they tend to simulate collaborative or nice failures that give you an error response and tells you what's happening. But in reality, it's much more complex. Sometimes you don't have any error return, you have just a hanging connection, and you need to deal with that, or even worse. And I think these are the most problematic errors, when you have random errors and random failures, but they do not fail all the time. They fail for 10% of the queries, but not always at this at the same time or this in the same way. So having said all of that, what would be a more useful benchmarking protocol? This is basically the question that we'll try to answer now. And for me, the first thing that we need to do is really preparing the testing setup. And in my opinion, this means that you need to start by having an observability solution that helps you actually get insights on what's happening in your system and your database in this case. So you need to be able to record and monitor the traffic shape, meaning the average and peak load, number, max and average and median number of query per second or transaction per second, the read-write ratio, how many of your queries or transactions are read-only transaction, how many of them are actually read-write transactions, the query types or the most, common query that are executed against your database, like are those involving joins, are those involving, primary key fetches, are those involving indexes, or and so on and so forth, yeah. The other thing as well to be able, of course, that you need to be able to record is the resource usage. How much I/O, CPU, memory, storage size, latency, network throughput that you are actually generating. And of course, you need as well to record any metric that might be exposed by the component that is important for your benchmark. And as well, very important, the configuration parameter, the effective ones, the ones that were actually used by the component at the time of the testing, so that you can understand later on, how those configuration parameter would have affected your performance benchmark. The other thing that is very important to do, in my opinion, is to try to use production-like data and production-like application traffic. So if you have already in a production environment, I think the first point is quite simple. You need to have backup from production that you use to populate your database, at least for the initial state. If you don't have a production yet environment, then actually you need to work with your intended users to work on simulating actually what would be, the initial state or a reasonable initial state for your database. The other important part that is often overlooked is, the traffic part, because it's one thing to have the initial state right, it's another thing to be able to replay, the traffic that was hitting your database. And there is no magic here. You need to invest in either implementing your traffic replay tools or, purchasing or using some products that would help you basically, capture some part of the production traffic and reinjecting it back into your own, testing lab or testing environment. You can as well create realistic workload simulators. So basically, between code dummy application that would emulate the behavior of your application, but of course not like in full scale, just trying to emulate the most common patterns. That is as well a viable and useful solution if trying to invest in traffic replay would be from cost or effort prohibitive. The other thing to do is really to use as much as possible the same stack that you are using in production, both on client and server side. And on server side, this means the number of nodes, the hardware that you are using, the replication durability configuration. If you are using proxy, then it is important to use as well the proxy in the same way as well. On client side, this would be the library and the driver and the proxy and the setting that you are using. All of that can significantly impact your performance figures. And the other thing that is worth keeping in mind is that it's very important to try to limit the noise effect, as much as possible. And by that, in order to do that, you can repeat your test a few times. I would say a minimum would be 3 times and more would be better. And then take average or median values, yeah. You need as well to be able to ignore the outliers associated with ramp up and down phase. It's always, common that in the ramp up phase, you have basically, not the same performance figures as you are in established mode, basically. And you need to try as much as possible to limit any shared resource that would result in a noisy neighbor effect. And we can do that to some extent by using dedicated bare metal machines, using, within that bare metal machine, virtual machines to isolate your component in the same VM, and simulate network delay jitter using tools such as net emulator, where the idea basically is to try to remove the impact of network that in many cases can be really of a big impact and can make the results not really usable. Yeah. Of course, you need to document the metrics you need to record and that you are going to use later on to assess whether a given change is improving or not the overall performance. Of course, those metrics need to reflect any SLA that you are bind to your end user, whether it's response time or number of supported users and so on. You need as well to record different percentiles, not only average or medians, because it's one thing to say that you are able to provide like seconds response time in average, and it's another thing to say that the best thing that you can do is to provide 10 or more seconds, response time at the 90% percentile or even more. You need as well to, and this is quite important and for me, is you need to divide the metrics by the overall cost of the solution. And this is just to factor in the cost of the solution and to be able to reason and to compare two different setup from cost perspective. Because if by introducing a change you are, I don't know, adding 10% of your overall throughput, but you are multiplying your cost by 2 or more, then probably it's not worth it if you can just increase by 3 or 5% and keep your cost by the same margin. Of course, again, if you are working in a setup where cost is not a concern, then again try to stay there. but I think for many people, at least from my experience, it's not the case. Limit the amount of changes in every test session. So this is another mistake, is at least I consider it a mistake, is to change a lot of parameters at once, then run a test session and try to draw a conclusion. And this is why it's a problem, because you don't know actually what change did cause that increase or decrease in the performance test. And therefore you will probably need to redo the test and to understand better and try to limit the number of changes again that you are doing. Then finally we can start running our test, and we do that by ramping up progressively the amount of allocated resources. So first thing to do, in my opinion, is to start by ramping up the clients, number of clients, concurrent clients, until we reach a peak, as we will see in the demo. And then if you can afford to increase more cores, then you can increase more cores, and then again increase the number of clients, and so on and so forth. If even you by using all the cores that you have at your disposals, you couldn't reach the number of concurrent clients that you need to reach, then the solution would probably go through a proxy. Okay, to use a proxy on top of the current stack that we are using, and the proxy can be both at server side and client side. Then the next thing to do, in my opinion, is to look at the memory allocated to your database buffers, because memory has always a big impact on performance. But you need to be sure that actually you are using that memory that is allocated. If the database is already using it's having a hit ratio of already 99%, then probably adding more memory will not be actually useful at all. And it might actually be the reverse. You might be actually slowing down the system in some cases. You need as well to ramp up progressively the allocated I/O capacity until reaching the peak achievable throughput. Meaning, if you are in a cloud environment, then you will start with one volume, and then either you extend the size of the volume, assuming that the cloud provider will as well add to this increase in size added I/O capacity. It's not the case all the time. You might as well need just to add completely new drive for that, and see actually if the I/O is a limiting factor or no. And it's the case, generally speaking, for databases, until you basically find your achievable throughput. Of course, we can say, okay, I mean, if we are I/O limited, why we don't add an infinite number of, not infinite, but a big number of drives and so on. And again, that might be, from cost perspective, prohibitive. And again, you might be limited by the latency or by other factors. It's not just about adding I/O capacity. Then, in my opinion, it comes, you need to start thinking about optimization client side. And for me, the things that you need really to do, because if not, they might actually make the results, not really reliable. So the things to do are connection pooling at client side, using prepared statement, using bulk insert, deletes, and updates. Okay, so as we did discuss, and as well, find a tuned fetch size for every statement that you are regularly updating. Of course, if the query is run once every, I don't know, day, then probably trying to figure out what's the best fetch size should not be your priority. Yeah? Here I'm really talking about the most used query in your system. Then I think you need to optimize the server side again by applying first the database management associated tuned config. So basically those are, tuned is a utility that helps you to apply different profiles, ccTL profiles, and this can have an important impact on the performance. Then in my opinion, you need to start now analyzing the indexes that are worth creating to accelerate your most common queries. So because you would have already monitored your system, you would be able to see like the most 10 used for example query, or when I say common used, or the one that are consuming most of your resources, and try to optimize those first, and so on, yeah? Until you get a decent performance from your perspective. Then the next step would be to review the parameter related to the number of cores. So here, if we take Postgres, it would be all the worker parameters in Postgres. Then you review the parameter related to memory consumptions, like all the mem, all the parameter containing memory, as in mem, and buffer parameters. And then you try to look at all the parameter related to I/O, and there are a lot of them. Here I'm mentioning the most important one that would contain commit, compression, and cost. And after doing all that, it's time to reiterate all those tests. Why is that? And this is very important to understand. It's because the parameter that we are changing each time, they might have actually an impact on the parameter that we did set up previously. And I don't think that there is, a better way to do it than, reiterating the process from the beginning, so that actually you are sure that you are not degrading other parts of the system by changing those parameters. And you might need to do this a few times until you find a baseline that first you are happy with, and that, it's hard, to improve open. And this is not the end, because even after doing all of that, now comes the part where actually you need to iterate the same test or the same kind of protocol while simulating different failure modes. And those different failure modes can have different types of failure. So network jitter variability, like when it's increasing or decreasing, is an important one. Hardware failures, obviously, you need to care about that when you are doing database design, like complete node failure, just the disk failure, and so on and so forth. I/O starvation, it means that what happens when you don't have enough actually I/O to serve your query as fast as you would like. Does all your other query queue and everything go sideways? And why this is important? Because it's the time, generally speaking, where you need to think about timeouts and set reasonable timeouts for the query, for the logs that the application are putting on the database, and so on and so forth. And because you would be changing some of the parameter, typically, as I said, timeouts, keep alive related settings, and those kind of defensive mechanisms, you might actually end up again changing the performance characteristic when you are working in normal mode. Yeah, and that's why the next step would be, okay, take some rest but reiterating as well the process, and as well keep testing with every new database or application release. And it's important that any change actually might have an impact from performance perspective, so it's important to try to do this as early as possible in the development process. And it's as well important to have baselines. So even if, of course, I would not expect you to have a full-fledged, production environment in your CI/CD, but at least you can use that environment to have a baseline. And when you have a new version of your application, you would compare it to that baseline. It does not mean that if you have, like a degradation of performance, that, it will be the case well in production, because the hardware might be completely different, and that, small degradation is not even visible in production. But at least it will hint you that something did change, and something probably worth investigating at that early stage. So that was about the protocol. I know it was long, but I think I tried to cover all the points that are worth mentioning there. Now we will move to the demo. So of course, in the demo, will not be able to cover everything, knowing that I already exceeded my time allocation by a bit. So in this demo, we are going just to show how we would go about it, like, for a very basic case for the number of clients, depending on the number of cores that I would have. So we start here by, installing LXD, our powerful manager for system containers and virtual machines. Then we create a VM to use as a playground. We allocate to it 6 cores, 16 gig of memory, and 32 gig of storage. We connect to that playground machine, and then we do the same, install LXD once again, so that we can have VMs within the VMs. We here just disable IPv6 because we don't need it. We create a VM that will act as, like the server side for Postgres in our case, and another VM that will act as the client side. Then we list actually those VMs just to record their IPs, because we will need them later. We go to the server side. After updating our packages, we install Postgres itself, and then we install a few extensions that I highly recommend to install, that are part of Ubuntu and that are part of our supported packages. We have more than 100 supported extension and tools around Postgres, and we do support them for 10 years, and we do test them together. So it's something that we can help you with at Canonical. Then and those like extension in particular will help you like to have detailed monitoring of your queries, and can help you understand what are the queries that would benefit, for example, from indexes. The next step would be to start logging, which is again as part of the monitoring requirement to be able to understand what's happening. And I'm not going to go the details of every line, but basically this will allow us to collect a number of information, and to have like automatic rotation without the need of external tools and so on, and having enough logging without exploding really the size of the logs. Just few things to note here is that the listen address, you should put it to the IP address of the node where Postgres, or the VM where Postgres is running. And you need as well to modify the shared preload library in order for PG statement and PG quellstat to be taken into account. And whenever you change the shared preload library, you need to restart Postgres. So that's what we are doing in the next comment. Then we connect finally to Postgres. We check that the logs are being sent to this location, so that to make sure that whatever we did in the from logging, let's say configuration is working as expected, we connect to, we connect to PostgreSQL instance. Before we were just connecting as the Postgres user. We create the extension that we did mention, and then we select all of them to make sure that actually they were successfully installed. Then we actually create a test database. I don't think we need to reconnect again. We connect to this database within, or we switch to this database if you wish within Postgres. We create a user demo with the password of your choice, and then we make the demo user owner of the test DB. And then we quit the terminal. We need as well to add the following line in the pghba.conf file that acts like a firewall, let's say database firewall in context of Postgres, and we need to add this line to allow clients coming from our other VM to reach and to be accepted by this database. After doing all of this, we go to the client machine and we install Sysbench, the tool that we are going to use in order to simulate some traffic. First, we start by this OLTP read-only prepare that will, populate, if you do like me here, with around 2 GB of data, your database. Then, we check actually that everything was inserted correctly, as I said. And between, every run, it will be useful to issue this query select pgstat reset so that you have a fresh new statistic, and one run will not impact the other run. The first thing that we are going to do is actually use only 2 threads and use OLTP read-only, that, as the name implies, is generating only read-only traffic in order to get, how many query per second we are having. And as I said, that we should do, I am here repeating my test at least 3 times. And then what I will continue to do is increase the number of threads and keep doing the same thing, and then record the number of query that I managed to get. And here you see that it continued to increase slowly, as I increase the number of threads. And then here, I put just a graph because I tested with all these values, and you will see that there is an optimal number, yeah? That in this case it's 8, and I remind you that I allocated 2 CPU, or actually 2 threads for this instance, and it's generally the case that for most databases, the optimal number of concurrent clients would be, equal to the number of cores or threads multiplied by a number. In this case, it seems to be 4 for Postgres. For some database can be more, for some database can be less. And we see that if we increase further the number of threads, actually we have diminishing returns, and we are not actually improving the performance. It's the reverse, we are worsening it. So all of this was just to say that, ramping up, as I said, is very important, slowly, and trying to find the sweet spot. So for this particular workload, it was 8. If you use the same test and use read-write or write traffic, you might see different optimal value. And I wanted just to show how sensitive actually, whatever benchmarking procedure you are having would be to some, values. And that's why I think the recommended protocol that I did show can help you have some consistent results and some repeatable results. So now let's move to the conclusion part. So first thing to keep in mind, I think, is that public benchmarks should always be taken with a grain of salt, because in my opinion, they are often not reliable. You need to monitor your database performance throughout some key metrics. And, without monitoring, you will not be able really to do any benchmarking in the first place, because you would not know how your changes are impacting the database performance. And then you need to build a realistic and repeatable and automated benchmarking protocol, following the recommendation that I tried to share with you here. that should both account for normal operation as well as degraded mode when there's a failure in the system. And that's very important because it has a lot of implication on your capacity planning. If you would like your database to have, pretty much the same SLA, provide the same service level agreements in terms of performance, at least with 2 nodes, or 3 nodes, then actually you should dimension the system in a way that your 2 nodes should be enough to handle all the requests. And that's why it's very important to conduct the same tests in degraded modes. Benchmarking should be regularly conducted as part of the development lifecycle. So this is we already discussed about. It's not a one project, it's not a one-time off thing and then you forget about it. You need to have this as part of your test. And in this presentation, we talked only about benchmarking as performance benchmarking. We can benchmark as well other types of attributes of the system, but that's what we did choose to do in this presentation. So that was all on my side. I hope that it was useful for you. Thank you for your time. And if you have any question, regarding your databases, I think we can help you at Canonical with our enterprise offering. So please do not hesitate to contact us via this form and have a good day. Bye.